Hey everyone, welcome back to another video. So today I'll be explaining physics paper 6 alternative practical code 0625 paper 62 May June 2015. Let's get started. Question 1 states the class is investigating a pendulum. Figure 1.1 and 1.2 shows the pendulum. So in figure 1.1 the bob is at its resting position. In figure 1.2 the bob is moving from one point to another point. Part A states a student adjusts the pendulum until its length L is equal to 50 centimeter. State one precaution that you would take to measure the length L as accurately as possible. You may draw a diagram. So first we will draw a clamp with a length of the rope attached with the bob, and then we will draw a ruler next to this clamp and the bob and mark this as ruler, and over here we will state this rectangle as clamp, and over here this circle will be a bob. And then in the statement we will write one precaution that you would take to measure the length L as accurately as possible. So I would measure the length using ruler perpendicular to it to avoid parallax error. So this will be the answer for part A of question 1. Part B states the student displaces the pendulum bob slightly and releases it so that it swings. She measures the time t for 20 complete oscillations of the pendulum. See figure 1.2. Record the time taken t in s shown on the stopwatch in figure 1.3. So over here we have the stopwatch with the time in seconds, and part 2 states part 1 we will write 28.4 seconds. So we will write 28.40. This will be the correct answer. So we will write 28.4 seconds. Part 2 states calculate the period t of the pendulum. The period is the time for one complete oscillation. So the time taken in part 1 was for 20 complete oscillation. We have to calculate for one oscillation. So 28.4 divided by 20 will be 1.42 seconds. So we'll write 1.42 s. We will write s. Part 3 states explain why measuring the time of 20 complete oscillation rather than one oscillation gives a more accurate value for t. So the answer will be you can easily start and stop the watch, because if you measure the time for one oscillation you have to quickly press the button twice for one oscillation, so the reading won't be accurate. So for 20 complete oscillation you can easily start and stop the stopwatch. Part C states the student adjusts the length of the pendulum until its length L is 100 centimeter. She repeats the procedure and obtains a value for the period t. T is equal to 2.06 seconds. So what the student is doing is using the length of the pendulum at 100 centimeter and repeats the procedure, obtains the time period t of 2.06. So another student suggests that doubling the length of the pendulum should double the period t. State whether the result supports a suggestion. So the statement will be no, because when the length was 50 centimeter, the time was 1.42 seconds. But when we doubled it, the time was 2.06 seconds. So this didn't double the time from 1.4 to 2.8. It only increased by 0.6 seconds. So justification will be it is not within the limits of experimental accuracy. So this will be the justification for part C. Part D states to continue the investigation of the relationship between the length L of the pendulum and the period t, it is necessary to use a range of values of length L. List additional L values that you would plan to use in the laboratory. So we have already used 50 centimeter and 100 centimeter. So we will use 20 centimeter, 40 and 60 centimeter for a range of values of length L to give a more accurate reading for the pendulum time. Question 2 states the class is investigating the cooling of water. Part A states a student pours 100 centimeter cube of hot water into a beaker. He places a thermometer in the water and figure 2.1 shows the thermometer. So this is the beaker in figure 2.1. Part 1 states record temperature costa H of the hot water as shown on the thermometer figure 2.1. So on the thermometer it is above 90 degrees Celsius and it is around 92 degrees Celsius. So what we will do, it's 2 bars above 90, so it will be 92 degrees. So in costa H we will write the answer will be 92 degrees Celsius. Part 2 states, state one precaution that you would take to ensure the temperature reading for the hot water is as reliable as possible. The answer will be view the scale of the thermometer perpendicularly to avoid parallax error. Why? Because if you will be looking at the thermometer from right side or left side, if you look at from the right side, the temperature will be 1 or 2 degrees less, and if you look from the left side, the temperature will be 1 or 2 degrees more. So this will create an inaccurate experiment. So this is how you can take the temperature of the reading of hot water more accurately. Part B states the student adds 50 centimeter cube of cold water to the hot water. He records the temperature costa 1. So the costa 1 is 71 degrees Celsius. Question states calculate the decrease in temperature costa A using the equation costa A is equal to costa H minus costa 1. So the costa H is 92 degrees and costa 1 is 71. So the decrease in temperature will be 92 minus 71, which will be 21 degrees Celsius. So the costa A will be 21 degrees Celsius. Question part C states the student adds further 100 centimeter cube of hot water to the water in a beaker. He records the temperature costa 2. So the costa 2 will be 57 degrees Celsius. Calculate the decrease in temperature costa B using the equation costa B is equal to costa 1 minus costa 2. So in previous question we have seen that the value of costa 1 was 71 degrees Celsius and costa 2 degree temperature is 57 degrees Celsius. So what we will do is 71 minus 57, which will be 14 degrees Celsius. So we write 14 degrees Celsius. So this is how we will do part C. Part D states suggest two factors other than the volume and temperature of the cold water added that affect the decrease in temperature of the hot water. So two factors other than the volume and temperature of cold water added can be, first is some heat is lost to the surroundings. Second factor is energetic molecules leave from the surface of the liquid, so the temperature of remaining molecules decreases. So these are two factors that affect the decrease in temperature of the hot water. Part E states describe briefly how a measuring cylinder is read to obtain an accurate value for the volume of water. You may draw a diagram. So we'll draw a meniscus and the answer will be read the volume of the water from the lower meniscus. Why? Because water has a curved facing doing its downwards, not upwards like Mercury. So if it is facing downwards or bending downwards, so you have to look from the lower meniscus, not from the top meniscus. If you look at the top meniscus, that will be inaccurate and the experiment will be non-valid. So this is how what we will write in part E. Read the volume of the water from the lower meniscus, not from the top meniscus or upper meniscus. Question 3 states, the class is investigating the resistance of lamps. Figure 3.1 shows the first circuit used. So this is the power supply, and here is the voltmeter, ammeter, and 3 light bulbs. Part A states a student measures the potential difference Vp across the lamps and the current Ip in the circuit. The readings are shown in figures 3.2 and 3.3. So figure 3.2 over here, the voltmeter shows it is more than 2 and it is between 2 and 3. So it is 2.4 volts. Then ammeter over here, it's more than 8 and it's on the second line. So it will be 0.84 amps. So the voltmeter shows a reading of 2.4 volts and ammeter shows a current of 0.84 amps. Next, part 2 states calculate the resistance R of the lamp filaments using the equation Rp is equal to Vp divided by Ip. So resistance is equal to voltage divided by current. Voltage is 2.4 and current is 0.8, which will be 2.86 ohms. So the resistance of the lamp filament using the equation will be 2.86 ohms. Part B states the student rearranges the circuit so that the lamps are in series. The ammeter will measure the total current in the circuit. Voltmeter will measure the potential difference across all 3 lamps. In the space below, draw a diagram of the circuit using a standard circuit symbol. So over here we will have this power supply, here we will have a switch, over here we will have ammeter, and across all 3 light bulbs we will have a voltmeter. So this is the diagram that we have to draw in part B of question 3. Part C states the student measures the potential difference Vs across the lamps and the current Is in the circuit in B. Vs is 2.5 volts, Is is 0.22 amps. Calculate the resistance Rs of the lamp filaments using the equation Rs is equal to Vs divided by Is. So using the formula, 2.5 divided by 0.22 will be 11.4 ohms. So we'll write 11.4 ohms. Part D states a student wishes to vary the current in this first circuit shown in figure 3.3 using a variable resistor. In the space below, draw a standard circuit symbol for a variable resistor. So what we will do is draw like this, and we will draw a line through this. So this will be a variable resistor. Then part 2 states on the figure 3.1, label with X a suitable position in the first circuit for a variable resistor used to vary the current in all the lamps. So back on the figure 3.1, where we have to draw this variable resistor, and the position will be over here, so that we can control all the brightness of the lamps. So this is how we will do part 2 of question D of question 3. Question 4 states the class is investigating reflection using a plane mirror. Figure 4.1 shows a student's ray trace sheet. The student uses an A4 sheet of plain paper. So this is a student's ray trace sheet over here, and the student used A4 sheet. So part A states on figure 4.1 the mirror is placed along the line MR labeled the normal NL. So first we will draw a normal line at point A using the ruler and a protractor, and draw a straight line, and we will label this line as NL because it's a normal line. Then part B states the student places two pins P1 and P2 on line AB at a suitable distance apart so that she can accurately observe the reflection of the line AB. Suggest a suitable distance between the two pins. So over here the student places two pins apart, and over here P1 and P2, and the question states suggest a suitable distance between the two pins. So the distance between the two pins must be at least 5 centimeter or more. So the answer will be 5 centimeter. Part B states the student determines the angle between the reflected ray and the normal by viewing the images of the pins P1 and P2 from the direction indicated by the eye in figure 4.1. She places the two pins P3 and P4 some distance apart so that the P3 and P4 and the images of the P2 and P1 all appear exactly one behind the other. She draws the line joining the positions of P3 and P4. She measures the angle A between the normal and the line joining the positions of P3 and P4. At this stage, the angle costa between the mirror and the line MR is 0 degrees, as shown on table 4.1. She moves the mirror to a new position, shown by the dotted line on figure 4.1 at an angle costa 10 degrees to MR. She repeats the procedure with pins P3 and P4. She continues using the costa 20 degrees, 30 degrees and 40 degrees. The readings are shown in figure 4.1. So these are the readings in table 4.1. Part 1 states plot a graph of A degrees y-axis against costa degrees x-axis. So this will be on x-axis, this will be on y-axis. So over here we have drawn 20, 40, 60, 80, 100 and 120, and over here on x-axis we have drawn 10 degrees, 20, 30, 40 and so on. Now what we will do over here is we will use this degree. At 10 degree it is 50, at 0 it is 32. So at 0 it is 32, so here 32. At 20 it is at 50, at 30, at 20 it is at 69, at 20 it is at 69, then at 30 it is at 92, at 92, and at 40 it is 108, at 40 it is 108. So this is how we will do part 1 of question C. Part 2 states state whether your graph line shows that the angle alpha A is directly proportional to the angle 0. Justify your statement by reference to your graph line. The statement will be yes, and its justification will be as costa increases, alpha also increases, so it is directly proportional. Because in the graph, the line was moving constantly throughout the graph, so it means it is directly proportional. Now, part 3 states suggest why when this experiment is carried out carefully, the points plotted may not all lie on the graph line. Draw thin lines so that this will increase the experimental accuracy. If you have thick lines, so you cannot measure the values from the graph accurately. So the answer will be draw thin lines. Question 5 states the class is investigating the image formed by a converging lens. Figure 5.1 shows the experimental setup. Illuminated object. Over here we have the figure 5.1. A student positions the illuminated object and the lens and then moves the screen away from the lens until a sharply focused image of the object is formed on the screen. The student measures the distances u and v as shown in figure 5.1. So the value of u is 25.8 centimeter and the value of v is 36.2 centimeter. Part A states calculate the focal length f of the lens emerging using the equation f is equal to uv divided by u plus v. Give your answer to a suitable number of significant figures for this experiment. So what we will do is 25.8 multiplied by 36.2 divided by 25.8 plus 36.2, which will be 15.1 centimeter. So the answer will be f is equal to 15.1 centimeter. Part B states state 2 precautions you would take in the laboratory in order to obtain reliable measurements when doing this experiment. The height of the lens and the object should be same height so that the accuracy will be increased, and this will make the measurements and the experiment more accurate and reliable. Second option or precaution can be record the length from center of the lens, not from one side of the lens or the other. It should be between the lens so that the length will be more accurate. So this is what we will write as 2 precautions you would take in the laboratory in order to obtain reliable measurements when doing this experiment. Again, the height of the lens and the object should be same height. Record the length of the from center of the lens, not from one side or the other. Question 5 part C states the object is figure 5.1 is an illuminated triangle as shown in figure 5.2. Suggest 2 differences between the appearance of the illuminated object and the well-focused image on the screen. So first it will be smaller because it's a converging lens, and second it will be inverted. When it's a converging lens, the object or the image will always be inverted. So these are the 2 differences between the appearance of the illuminated object and the well-focused image on the screen. So this is what we will write in part C of question 5. So guys, if you like this video and are clear with this paper and with all the answers that you were confused in, don't forget to subscribe, like this video and share it with your friends who need help in this paper, and tell them to subscribe to this channel. See you in the next video. Bye.